All right, lesson 233. Forgot to do this, record this Friday, so I'm doing it today so we can get rolling with this. So, lesson 233, graphing tangent. So we've graphed sine and cosine. We've graphed inverse sine, inverse cosine. So what does tangent look like? So today's lesson investigates graphs of tangent lines and inverse tangents. So understanding what is tangent. Okay, tangent is sine over cosine. So when we think about our triangle, we're talking about, we learned that, sine is opposite over hypotenuse, okay? Opposite, hypotenuse, adjacent. Cosine is adjacent over hypotenuse, okay? And then tangent, we always learned as opposite over adjacent. But if you think about that as sine over cosine, okay, with the hypotenuse being 1 on our unit circle, sine is technically the opposite, cosine is just the adjacent because it's over 1. And so then tangent becomes sine over cosine, or opposite over adjacent. So sine over cosine. So when we're graphing this tangent graph, the first thing we need to consider is what gives us problems. Okay, and so it says, when does cosine equal 0? Well, why is that a problem? Because we can't divide by 0 in math. So when we have the denominator of 0, we're going to get a vertical asymptote. So when we're graphing this, okay, so looking at graphing tangent, okay, where on the unit circle is our cosine, which is our x values? We should know that by now. Okay, where are our x values going to be 0? Well, this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. So where are our x values 0? At the top and bottom, or pi over 2 and 3 pi over 2. So when we're graphing this, we already know at pi over 2 and at 3 pi over 2, we're going to have vertical asymptotes. Okay? Why? Again, because it's going to make the denominator 0. Okay, so it's going to happen at a period of every pi. So every pi, pi over 2, 3 pi over 2, 5 pi over 2, okay, every time we have that distance, we're going to have another vertical asymptote. So this would also happen at negative pi over 2. We're also going to have a vertical asymptote there. Okay? All right, the next piece of investigating on our tangent graph would be if sine's 0. If sine's 0, we know it's crossing the x-axis, it's x-intercepts, right? Because it doesn't matter what cosine is as long as cosine's not 0 also, which they can't both be 0 according to the unit circle. Okay? Where is sine 0? So we just marked out the top two. Well, sine's going to be 0 at 0, pi, 2 pi, and keep going. Again, so where are those values? 0, 0, okay, at pi, at 2 pi, right? We're going to keep getting these zeros. Okay, and then looking at the unit circle, where are these graphs, what are they doing, right? So, as we move, right, across, as we move sine over cosine, so let's just think about our first point here. At pi over 6, we have a value of square root of 3 over 2 over 1/2. Okay, that's our coordinate. And I said over 1/2 because it's sine over cosine. So, 1/2 over square root of 3 over 2. Okay, well, our rule is dividing fractions, right, is multiplied by the inverse. Okay, our 2's are going to reduce there. We're going to have 1 over the square root of 3. And if we rationalize this, we're going to get the square root of 3 over 3. Okay, or what's happening, right? We have a small fraction. Okay, so this is going to start out this way, right? And the closer we get to 1, the more this graph's going to become vertical. And the same this way. So our tangent graph is going to be very similar to this, and it's going to continue. Okay, over and over again, it's going to repeat. Okay? So notice that with our tangent graph, again, we've already established this, but our period is pi. Now, why is it pi and not 2 pi? So with sine and cosine, our period's been 2 pi, or 1 lap around the unit circle covers all the sine values, positive and negative. Well, if you think about tangent, it's sine over cosine. Okay, so every sine value is covered from 0 to pi. Okay, positive and negative. Excuse me, only positive, right? But cosine is going to be positive and negative. But what happens when I go to the bottom half of the circle? Well, sine becomes negative, but cosine is going to be positive and negative. So if you think about quadrants, positive, positive. Okay, well, if I'm dividing that, it's going to give me all positive answers. Over here is going to be negative, positive. Well, if I divide those, all negative answers. Well, then come to the bottom of the circle. Negative, negative. But if I divide those, all positive answers. Positive, negative. If I divide those, all negative answers. So again, I'm going to cover all those same answers and signs by only touching the top half of the circle, and then they'll repeat on the bottom. So my period is only 1 pi for tangent because it's division. It's sine over cosine. Okay, so asking this, what is the domain for tangent? Okay, domain, left to right, x values, all real numbers except pi over 2, right? And that's going to happen plus or minus pi n. Every pi, we're going to have that asymptote. So my domain, all real numbers except pi over 2 plus or minus pi n. So every time that occurs, and I'll write this out for you guys so you can see what I'm saying here. Every time that occurs, asymptote. So the domain, all real numbers except x cannot be pi over 2 plus or minus pi n number of times. Ever how many times that occurs. Okay, what is my range? Range, bottom to top, or y values. Again, all real numbers. Okay, all y values are covered. Okay, next question. X-intercepts of the function. Well, that happens every pi. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. It keeps going on. Okay? We've already talked about where are the asymptotes. Okay? We've talked about the period. So, let's talk about inverse tangent. So, what happens when we have the inverse tangent? Okay? So, we've been doing this carbon copy method. So, again, when you take your graph and you flip that graph about the line y equals x, right? And then you trace over it with a pencil, fold that paper over, rub, get the lead to actually show up, carbon copy it. It will actually show you the inverse, okay? But the easiest way to do this for the sake of time is to I'm just going to put this into Desmos and show you what happens. So we should have known that with our sine and our cosine graphs, the initial graph was horizontal. Okay, it was this horizontal oscillating wave, right? And so we see now, where we saw that with their inverses, it became vertical. Well, if you look at tangent, these are more of a vertical looking graph. Okay, so what's probably going to happen with an inverse? Yeah, I mean, you probably guessed it, right? probably going to go horizontal. So if you look, I've got our Desmos pulled up here, and you can see that it turns this tangent horizontal. Okay? So that's a pretty good look at it there of what happens. Okay? It turns it from vertical to horizontal. Kind of like a cubic function would look, right? Very similar to a cubic curve and then a cube root curve. Very similar to what that looks like there. It just repeats. Okay? So that's kind of neat there, inverse tangent, right? So then the last thing here describes transformations. So if we're talking about transformations of these graphs and what they look like, it's the exact same as we've been doing with all transformations. So let's see here if we can come up with these using tangent. So basically, we're using tangent. They want us to write the equation of a tangent that is shifted left pi over 4 and up 1. So we're shifting tangent left pi over 4. So again, that's an horizontal change is inside of the function, right? So inside, it's left, so it's opposite sign, pi over 4, and then up 1. Vertical change is outside, right? So it's outside of the function, we add 1 to it. Okay. B. Shifted right pi units down 2. Again, right pi down 2. So again, horizontal changes where? Inside, opposite the sign. So x minus pi, the right pi, and then down 2. Down is where? Outside of the function. Vertical change is always outside of the function. Minus 2, shifting it down 2. Okay? We have a vertical stretch by a factor of 3, and then reflected horizontally. Okay, vertical stretch. Okay, again, vertical outside the function, stretched by a factor of 3. Stretch is always in front of the function, right, by that factor of 3. So 3 tangent, and then we have a horizontal reflection. Okay, horizontal is always inside the function. Reflection, or a flip, in other words, is just creating a negative inside of the function. Okay, and then the last one, D, just says a tangent graph that has a period of pi over 2. Now, we have to be careful, because when we've talked about period with sine or cosine, it's always been based off of 2 pi. So we've had 2 pi divided by b, or that value that we're plugging into the function. Okay? But we have talked about today, what is the period of our tangent function? It's actually pi. So now tangent is based off of pi. So we want this to be a period of pi over 2. So what does this b value have to be? Has to be 2. So 2 is what, that b value is what goes into the function. Okay, so again, writing this function out would be tangent of 2x. Okay, 2 being the b value that we put into the function to change the period. Okay, so that is graphing tangents. That's graphing inverse tangent, or what it looks like. And then also being able to transform these a little bit. So that's lesson 233. And the gist of what we're doing there is graphing tangent and inverse tangent. And that ends unit 2.